In this video, I'm going to show you how to go from an image like this, and then using your Darknet YOLO network to show the predictions like this, and then go one step further and then blur some or all of the predictions like this. All right. Let's start fresh. I'm going to clear what I have here. Let me show you in my neural network directory, I have a network that I trained. It's called Mailboxes. It's a YOLO v4 tiny network. In images, I have just a few example files. These are similar to the ones that I used to train the neural network. There's 5 files in all. And then we have this file here that we're going to start. All right. We're going to load our neural network. So that's in the NN directory. Mailboxes CFG. What am I missing here? The weights. Mailboxes best dot weights. We're going to set a couple of things. What else do I want? Annotation, I want auto hide label to be false so that we can see all of the labels, and we don't need the duration as well. All right. Here's the actual neural network using that configuration. And we're going to use C++17, the file system, to iterate over the images, load them one by one. What else do we need? Let's load those images. So an original image. I'm not going to bother checking for errors here, but you should check to make sure that the original image is not empty. In this simple test, what we want to do is we're going to call the neural network predict original image. You can pass in the path to predict as well, instead of loading the image into a CV map. And we should probably do all right. Let's see those as well. So what we need to do here is CV item show. The original image, and what do we need to do here? Let's try around 1000. This is all running in a VM. I use VirtualBox for almost everything I do. And then annotated image is what we want. You know what? Let's do it up here. So we also have an annotated image. I don't normally use gedit for my code development, but just for this little demonstration here, thought it would be easier than having to set up an entire project. Kdevelop is what I typically use as an IDE. Let me just show you the CMake file. Now this is taken from the example project in the DarkHelp. That comes with the DarkHelp library. So it's really simple. I have to use C++17 because I'm using file system. Otherwise, DarkHelp, I think, only requires C++11. We're going to find threads, which is typical, OpenCV, and then we're going to tell it we also need the library for DarkHelp, and DarkHelp also needs Darknet. We're going to set up our include directory so that we can find all of the OpenCV includes. And this is what builds the example out of example CPP. So that should be fairly simple. Now we have a build directory. We do this. Clear, make, and let's run it. Helps if I fix errors first. 1, 2, 1, 2. Okay, I know what I did wrong. I need a CV key over here. That way we can actually see the windows. Okay, so we have our annotated image and we have our original image. So everything's pretty straightforward. Every time we hit a key, we're going to go through that loop and we're going to see the next image. There are 5 of them in all. You can see the output here, which is generated by this line over here. So now to get the blurred objects or the pixelated objects, what we're going to do is annotation pixelate enabled equals true. Let's see if that works. Perfect. So now we have, instead of having just the regular bounding boxes, we have pixelation that's happening. Let me get a drink here. And you can alter that pixelation. Annotation, pixelate size. I actually forget what the default is. It might be 10. Let's see. So with the 5, what it means is it's using smaller boxes to pixelate, and now we can actually still read the numbers. If we do the opposite and we go for 25, that means it's using boxes of 25 by 25 pixels. And now we can't read the numbers anymore, and you can't even see that it's a lock anymore. So depending on the objects that you're pixelating and how large those objects are and how recognizable you want them to be, like if you're pixelating someone's face, you might need to alter the default pixelation size. The other thing that's hopefully convenient is you can pixelate just some of the classes. Pixelate classes equals, and this is a standard set of size T representing the class IDs. So the class IDs start at 0. 0 in my case is lock. And then after that, like 1 corresponds to the number 1, 2 corresponds to number 2. I did it really simple. Let's do evens. So 0 will be the lock, and then even numbers after that. Do I need to do anything else? Don't think so. And what did I do? Oh, that's what I did. There you go. So now all the odd numbers, I told it I'm not interested in pixelating those. So number 1, 3, 7, 9, those ones are showing up normally. And the ones that are pixelated is class ID 0, which is the lock, 2, 4, 6, 8, and then I didn't do 10 and 12. So this way you can pixelate really easily just some of your classes and leave the other ones with the normal bounding boxes, but they don't need to be pixelated. So if you have, I don't know, if you have your neural network that detects dogs and cats and people or people's faces, that way you can make sure that the class that represents people's faces is pixelated, but everything else is left untouched. Is there anything else I can show? I think that's about it. So hopefully this is useful for you guys. Let me iterate through slowly just one more time. And the key here might be the pixelation size. So you'll have to adjust the pixelation size based on the objects that you are using, the size of those objects and the size of the images. And you can do that dynamically too. It doesn't have to be just one time here. You can do it, I guess I'd have to do it here. So neural network, config, annotation, pixelate size equals, and then whatever you want. So here, even though up here I set it to 25, now over here when I set it to 5, this is the one that should take effect. The line that sets it back to 5. Yeah, and that's indeed the case. You can see here that you can still read the numbers. And of course, right now I've only got the even classes that are pixelated and the odd classes that are not. And again, you could change that. You could remove annotation pixelate classes equal, I guess you could just do it clear here. Or you could set some other criteria. Yeah, so now all the classes are pixelated, and they're only pixelated with a size of 5 pixels. I'll see you guys on the Discord, or send me an email if you have any suggestions. Thanks.